Hello students, in this video I am going to talk about the practical information regarding Kirchhoff's voltage law. Let us start with the same. So this is first of all the circuit diagram which I have considered. This circuit diagram consists of total 5 resistances named as R1, R2, R3, R4 and R5. This is the arrangement that we are supposed to draw on the breadboard. And Vs is the input voltage, the power supply which we will be providing. Now, the value of the resistances that we are going to consider. So, I am going to consider all the 5 resistances R1 till R5 to be equal to 1 kilo ohm. Whereas, the power supply Vs which I am going to consider is equal to 5 volt. And then we will try to verify Kirchhoff's voltage law which will be applying on 2 different loops. So here comes Kirchhoff's voltage law. As per KVL, it says that the algebraic sum of all the voltages around any closed loop or path is 0. So let us apply KVL in the given circuit diagram. We have 2 loops, loop number 1 and loop number 2. So in loop number 1, the equation will be minus Vs plus V1 plus V2 plus V5 is equal to 0. On the other hand, in loop number 2, the equation comes out to be equal to minus V2 plus V3 plus V4 is equal to 0. You can also check my KVL and KCL video to understand how to write down the equations with the help of KVL and KCL. So now I am going to discuss the voltmeter connection because voltmeter is used for calculating the voltages in our circuit diagram, and voltmeter is always connected in parallel. So now let us discuss how the connections will be there. So first of all, if I am going to connect voltmeter like this in parallel with R1, so here you will be having positive, here you will be having negative. So this will give us the voltage V1. Similarly, voltage V2 with the help of voltmeter connected in parallel with R2. Voltmeter connected in parallel with R3 will give us V3. So this is the positive and this is going to be the negative. Similarly over here, positive and negative. And R4, connect voltmeter in parallel with R4 will give us V4, and finally voltmeter connected in parallel with R5 will give us V5. So these are going to be our connections. So you need to connect voltmeter one by one with all the 5 resistances. Hence, you will be able to calculate Kirchhoff's voltage law. And then you just need to substitute all these given values in the equation which I have just discussed with the help of KVL, and you will be able to verify KVL. Although while doing the practicals, the chances are that you will be able to get some kind of errors, but that is acceptable. Now let us discuss how the connections will be done on breadboard. For the working of KVL, Kirchhoff's voltage law, we are supposed to connect 5 resistances together, and all the 5 resistances will have 1 kilo ohm resistance. 1 kilo ohm means brown, black and red. So let us start making the circuit diagram. So this is the first resistance. Here I am first of all making terminal B. What is terminal B? Where R1, R2 and R3, all 3 are connected together. Hence, all these 3 connections will be done in a single column. So here we have R1, this one R1, this one R2 and this one is R3. So I have connected R1, R2, R3, all 3 in a single column like this. So R1, R2, R3. Next is R4. So the one terminal of R4 is connected with R3 and the other terminal is connected with R2. Finally R5. So this is the resistance R5, which is going to be connected one terminal with R2, other terminal with power supply. So one terminal I have connected with R2, and the other I am going to connect with power supply. So here I have taken power supply, set it to 5 volt first, using channel A, so A must be pressed over here, 5 volt. So initially positive, so positive is connected with the first terminal of R1 and the negative is going to be connected with the other terminal of R5. So this is our connections for KVL, Kirchhoff's voltage law. Now let us start checking the value of our voltages one by one. Let us first of all calculate the voltage across R1. So positive will be connected with the first terminal of R1 and negative will be connected with the second terminal of R1. So let it be stable. So the value comes out to be equal to 2 volt. As you can see, the value comes out to be equal to 2 volt, that is V1. Next, let us calculate V2, that is the voltage across R2. So I am just going to replace this across R2. So voltmeters are always connected in parallel. Parallel means both the terminals directly connected with both the terminals of resistance. So V2 comes out to be equal to 1.2 volt. The third is V3. So V3 means the voltage across R3. So this is our resistance R3. I have connected both the terminals of my voltmeter across both the terminals of R3. So it comes out to be equal to 0.5. Next is V4. So for V4, let us connect the voltmeter across R4. So I have connected across R4 and this value again comes out to be equal to 0.5. V4 is equal to 0.5 volt. And finally V5. So V5 is nothing but the voltage across R5. So that comes out to be equal to 2 volt. By inserting these values in our KVL equations, that is loop number 1, loop number 2, and inserting the values, you will be able to verify left hand side is equal to right hand side.